Well, we're going to look at 2.3 operations with functions. This should look familiar. You've done this before in algebra, I'm sure. But you know, when you have take the sum of functions, you can add them, we can subtract them, we can multiply them by some number, and we can multiply two functions together, and we can also divide, provided that g sub x is not equal to 0, right? Because you can't divide by 0. So, but what you probably haven't seen before is, or talked too much about, is that let d of 1 be the domain of f and d of 2 the domain of g. Then the domain of the sum, difference, and product of f and g is the domain of 1, and this little symbol here means the intersection of the domain of 2. So you got to find their intersection or their overlapping area. And the domain of the quotient of f and g, so the division, it's still the intersection, but you have to take away whatever function, part of the function, it comes out to be 0 because you can't divide by 0. So such that g sub x is equal to 0. So you got to take that part of the set out. Now let's go ahead and look at a problem and see how this works. So we're going to look at example 14. Good. So I'll just go like this. And the first one it asks us is f plus g, right? So the domain of f plus g is going to be the intersection of f plus g, f and g. So they share a -2, right? So that's an intersection. There's a 1 here, but there is no 1 here, so that's not part of the domain. There's a 2 here, and there's a 2 there, so they share 2. And then 3, there's no 3 in the domain. So this is the domain of f plus g. Next is g minus h. So g minus h, the domain of g minus h. Well, let's see, there's a -2. There's no -2 in the domain of h. -1. There's no -1, 2. There is a 2, so I can put a 2 in there, and 4, but there's no 4 in the domain of h. So the domain of g minus h is just 2. Next is f times h. So f times h, let's see, that's the first and the second one. -2, is there a no -2? 1. There is a 1. And 2. There is a 2. And then 3, there is no 3. So this is the domain of f times g. Now for the quotient, the last one, they want us to do the domain of f over g, right? Well, let's see. Well, we have f over h, my bad. I almost made a mistake there. F over h, right? Well, we have f of h is here. It's 1 and 2, right? But we got to double check something here, because I got to subtract if any one of these, when domain comes out to be 0 in the range or in its output, then we have to get rid of it. And sure enough, h 1 goes to 0, right? So I have to take away the 1. So the domain is just equal to 2 for this guy, because when I put for this coordinate, for this input of 1, it comes out to be 0, and that can't happen, and that's that property there. So there you go for that. Now next operations we're going to look at is composite functions, and I'm fairly certain too you've done composite functions again, but we're going to talk about a little more thoroughly is about the domain. So it says f and g are functions, then the notation of the composition of functions f and g, and this is read f of g, and f of g of x is equal to f of g of x. For f of g of x to be defined, the range of g must be a subset of the domain of f. So you have to be careful looking at it. And vice versa, g of f, then then f must be a subset, what you're plugging in, of g, so vice versa. So you have to be careful with the domain there. So first, first, let's look at example 15. And it says first determine the domain and range of f. So the domain of f, this is f, that's all real numbers. So that's good. The range of f is going to be y such that y is greater than or equal to 0, because that's a quadratic, it's opening up, it's going in, its vertex point is right at the origin 0, 0. Now the domain of g, this is a root problem. I know that the domain of g is going to be x such that x is greater than or equal to 2. And if you wanted to find that out, you solve this for this can't, it has to be strictly greater than or equal to 0. You add 2, and that's how I got this. Now the range of g, this is a root problem, and I know that that's going to be y is greater than or equal to 0, just like that. Now b asks us to find f of g sub 1, and so g of f of 1. The easiest way to do this when they give you an actual value is find out what f of 1 is first. F of 1 is 3 times 1 squared, which is 3. Now I know this value, and I can say g of 3, and now I can plug that into g, which is 3 minus 2, which is just going to be 1. Good. Next to, it asks us to find f of g of 3. So what I'm going to do first is find g of 3. What's g of 3 equal to? Well, that's going to be 3 minus 2, which is also going to be 1. So now I can find f of 1, which is going to be 3 times 1 squared, which is 3. So those are my answers for that one. And then the last problem, the last one we're going to do is, now it tells us to find f of g of x and g sub f of x, and then determine the domain and range of the composite functions. So for C1, I'm going to say find out what f of g of x is equal to. Well, that's the same as f of g of x. So that means I got to plug g of x into f. This guy goes into here, so that's going to be 3 square root x minus 2 squared, which is 3 times x minus 2, which is 3x minus 6. That becomes a linear function. And linear functions are all real numbers, but for finding the domain, I have to consider the subset of what we plugged in, which is x minus 2, and we know that domain we found right up here is this guy, right? So I'm going to say that the domain of f of g is going to be equal to x such that x is greater than or equal to 2. And the range of f of g is going to be, since I have to consider this range, right? So that means that y such that y is greater than or equal to 0. Good? Now, 2 asks us to do the other way around, g sub f of x. So I'll go g of f of x, which is equal to g of f of x, which is equal to, I got to plug that guy into this guy, so I'm going to get the square root of 3x squared minus 2. Now, what's different here is now what we plugged in was all real numbers, right? So, so that's all real numbers. So, but here I have a new one. I have to consider that. So I have to find out when this is greater, when this is a negative number, to find out the domain. So x squared minus 2 is not equal, it's greater than or equal to 0, right? We need that to happen for the domain, and I'll add 2 divided by 3, and I get x squared greater than or equal to a 2/3. Take the square root, this turns into an absolute value problem, and when I take the square root of that, it's going to be the square root of 6 over 3. You can go ahead and check work here by rationalizing the denominator. So what does this mean right here? That means I know that my domain of g of f is going to be x such that x such that this the negative width x such that it's got to be less than or equal to a negative of this root 6 over 3, or x has to be greater than or equal to root 6 over 3. Kind of running out of space here, sorry guys. A little bit messy in there, right? So it's got to be smaller than the negative of this and bigger than the positive of that, and our range of g of f is going to be y such that y is greater than or equal to 0. Both of these, this is a root problem, but also if you look at, you look at this y has to be greater than or equal to 0. So there you go.